This video is over section 5.5, applications of linear equations and modeling. For this first half, we are going to be mainly using point slope form, and it's very intuitive what you use this for. You use this when you are given a point and a slope. So this is the formula, y minus y1 equals m times x minus x1, and the point will be x1 comma y1, and the slope, as always, or almost always, will be m. So we're going to be using this this formula for this first section. Pretty straightforward. It says use point slope formula to write an equation of a line having the given conditions. Write the answer in slope intercept form if possible. So we're going to start with point slope form. So just to keep my notes clear, I'm going to start with y minus y1 equals m times x minus x1. And then it wants us to write our answer in y equals mx plus b. So we're going to start with the point slope and finish with slope intercept. Okay, so this first problem says the line passes through -3, 2, and the m, or the slope, is -2/3. So this is going to be my x1, and this is going to be my y1, and they gave me m. So my formula, I'll use orange, is y minus y1 equals m times x minus x1, and I'm going to plug in y1, m, and x1. When I do that, I'm going to have y minus, my y1 is 2, equals, my m is -2/3, parentheses x minus -3. So here's just like a weird part. The formula has a minus sign, and what I'm plugging in has a minus sign, so it's kind of like x minus -3 becomes +3. So I went quick, but that is a review topic. If you have a question, just let me know, but that's pretty basic. Okay, so this is point slope form. And it also wants slope intercept form. So to switch the form, the first thing we're going to do is distribute this -2/3. So I'm going to have y minus 2 is equal to -2/3 x minus, and then if I do 2/3 times 3, the 3's basically cancel out, and I'm just left with -2. Next, I'm going to add 2. And on both sides, the 2's cancel, so I'm left with y equals just -2/3 x. And that is my slope intercept form that I wanted. The intercept on that would just be 0. All right, next problem, it says passes through 4, 4, and the slope is 5. So let's label this first, x1, y1, and they gave us m. So my formula for point slope form would be y minus y1 equals m times x minus x1. Again, I'm going to plug in for y1, m, and x1. And when I do that, I'm going to have y minus 4, luckily they're both 4, equals 5 times x minus 4. And this would be my point slope. So if the problem asks for point slope, you could stop there. I do want slope intercept, so I'm going to distribute this 5, and I'm going to have y minus 4 is equal to 5x minus 20. I need to add this 4. When I do that, I'm left with y equals 5x, and then -20 plus 4 would be minus 16. And there I have my slope intercept. Okay, these next two are a little bit tougher, just because you have more room for error, not because it's harder math or anything. But on this one, it says the line passes through 3, 5, and 5, -10. They don't give you m, you have to find m. So we're going to label both our points x1, y1, and x2, y2. So we have 2 points, so in order to find m, we're going to do y2 minus y1 over x2 minus x1. So we have to find m before we can use our point slope formula. So when I do this, I've got -10 minus 5 over 5 minus 3. -10 minus 5 would be -15. 5 minus 3 would be 2. So my slope would be -15 over 2. I'm going to use my point slope formula. So y minus y1 is equal to m times x minus x1. I'm going to be plugging in for y1, m, and x1. And I'm going to get y minus 5 is equal to negative 15 over 2 times x minus 3. This is point slope form. Okay, I want slope intercept form as well, so I'm going to distribute this negative 15 over 2. I'm going to have y minus 5 is equal to negative 15 over 2x plus 15 times 3 divided by 2 is just going to be 45 over 2. Double check that. Yep, and then I need to add 5 to both sides. And I got y equals negative 15 over 2x. And then 45 over 2 plus 5, I'm going to have to use my calculator, would be 55 over 2. And this is slope intercept. Note right here, you could plug in either point. So there are more than one right answer for point slope form. And then if you were to solve, you should get the same answer. If you didn't, you did something wrong because you should get the same answer whether you plug in x1, y1 or x2, y2. All right, same type of problem. So we have x1, y1, x2, y2. We have to do some work to find slope first. Let's use orange for the formula. So for my slope, I'm going to do y2 minus y1 over x2 minus x1. And that gives me 0 minus negative 2. Again, minus negative becomes plus. And I've got negative 1 minus negative 4. Oops. Which becomes plus 4. So I'm left with 2 over 3 as my slope. I said I was going to use a different color. Hold on. Change these to blue. All right, so we have our slope, and then I'm going to use point slope form. So y minus y1 equals m times x minus x1. And again, you can plug in x1 and y1 or x2 and y2. I'm going to do the second one just to show you that you can use 2 here as well. So this would be y minus 0 is equal to 2/3 times x minus negative 1. Note here, like you have to use this, like the buddy. Like you can't use like pick and choose like this one and that one. Like they have to be the same point, the whole point. All right, so this is point slope form. And I'm going to distribute. And notice here, I'm also just going to get rid of that 0. So I'm going to have y equals 2/3 times x is 2/3 x plus 2/3 times 1 is 2/3. And this is my slope intercept form. Really quick, I'm just going to show you that if you plugged in the other point, you'd get the same thing. So if I plugged in the other point, I would have y minus negative 2, so plus 2, is equal to 2/3 times x minus negative 4. The math is just a little bit uglier. So if I distribute here, I'm going to have y plus 2 is equal to 2/3 x plus 8/3. If I subtract 2 from that 8/3, I would be left with y equals 2/3 x plus 2/3. So we get the same thing plugging in either point. I just chose this one because it had a 0, so it's a little bit easier to work with. All right, this application problem says a small bakery makes donuts and sells them at the fair. The fixed monthly cost, for the use of the health department approved kitchen and rental space at the fair is $660. The cost of labor, taxes, and ingredients for the donuts amounts to 19 cents per donut, and the donuts sell for $4 per dozen. Okay, it says write a linear cost function represented C of x to produce x donuts per month. So C of x is the cost, and there's a fixed monthly cost of $660, plus there's a cost of 19 cents per donut, so that would be 0.19x. Write a linear revenue function representing the revenue R of x for selling R donuts. So we get revenue for $4 per dozen donuts, and X would be per dozen donuts. I think there's a typo here. Yeah, because it says per donut here. So we really need to multiply that by 12. So let me erase that real quick and do 19 cents times 12. This would be 228. Because X represents a dozen donuts, not one donut. So I'm just going to write here, multiply by 12. Okay, so for our revenue, $4 times X for each dozen of donuts, because X is dozen of donuts. All right, C says write a linear profit function, so P of X, representing the profit for producing and selling X dozen donuts, so again, X represents dozen donuts, in a month. So the positive part would be the 4X, and then each month we have to subtract. Well, here, let's show our work a little bit better. So for for profit, we're going to take our revenue minus the cost every month. So that would be 4X minus, and then the whole cost function would be 660 plus 228X. Part D says to determine the number of donuts in dozens that must be produced and sold for a monthly profit. So profit would be, we need a positive value here. So we want P of X to be greater than 0. And it will be greater than 0 if, let's just go ahead and plug in 4X minus 660 plus 228X. And again, we want that to be greater than 0. And if I simplify this side, I'm going to have 4X minus 660 minus 2.28X. And again, we want that to be greater than 0. If I combine those, I have 4 minus 2.28. That's going to give me 1.72X minus 660 greater than 0. I didn't run out of space. I'm going to add 660 to both sides. And that's going to give me 1.72x needs to be greater than 660. Divide by 1.72. And x is greater than it's a big decimal, 383.72. So we need to think about what this means in the context of the problem. X means dozens of donuts. So we need to sell at least 384 dozen donuts to make a profit. That's quite a bit. All right, part E says if 155 dozen donuts are sold in a given month, how much money will the business make or lose? So we're going to plug in 155 in for X. So P of 155 is what we're looking at. And I could go up here to this function, but I already simplified it right here. So notice here is a simplified version of P of X. I didn't move anything yet, so I'm going to use that instead. So I'm going to have 1.72, and then instead of X, I'm plugging in 155 dozen donuts minus 660. Because we know we needed 384 to make a profit, we know this is going to be a loss. We're just curious by how much. So when I do the math on this one, I'm going to do 1.72 times 155 minus 660, and I'm going to get negative 393.4. So what that means in the context of the problem is if 155 dozen donuts are sold, the company will be at a loss of $393.40.